If we rearrange what we did in question 1, let's just run through that. So we knew that the upper end for mu was x bar plus k sigma over root n, and this therefore gives us the distance from x bar to the upper end of our confidence interval. So k sigma over root n, we want to be a particular width in any given situation. So rearranging root n is k sigma over w, and therefore n is k sigma over w all squared. Now actually we want that to be greater than or equal to that, and this one would be a less than or equal to there. So that's where this formula is coming from, and can we apply it here? So the mass of supermassive black Tic Tacs containers is 153 grams with a standard deviation of 6.4 grams. A sample is to be carried out, and we want to be 99% confident that the mean of the sample is within 2 grams of the population mean. How large should the sample be? So all we need to do is find the correct k value, and then we have everything we need. So n is greater than or equal to, and the correct k value for 99%, which we can find from the calculator, is 2.576. Times that by 6.4, which is the standard deviation, and divide by the width that we want, which is 2, and square it. So n is greater than or equal to, if we calculate that, 67.95, and we'd have to round up, so n needs to be 68. Do we need to do it that way? Well, no we don't. We can do the other thing that we did in example 1 on the calculator. Before we start that though, let's just have a quick look at what we're doing. So the mean we know is 153, and our confidence interval would be like this, but let's just go one side. We want this to be 155, and that needs to be half of 0.99, so 0.495. And then we'd have the same on the other side by symmetry, meaning 0.99. So we want to find the value of n so that this happens in a gap here of 2. So, action, advanced, solve. Then we want 0.495 is equal to interactive, and let's go and find the normal CDF. The lower is the mean that we have here, 153. Actually that's the mean. And then the upper is 155, so that's all good. The sigma, we know that 6.4 is the standard deviation for a single reading, so we need to divide that by the square root of n. I'm going to use x here, and the mean is 153, and OK that, and it finds us the 67.94 again, and so we can go to 68 if we round up.